Section 8.2, Arithmetic Sequences. My printer did not print the top of this line. I apologize. I hope it's very clear anyway. In 8.1, we talked about sequences in general, and we learned that they were a function where you're only allowed to plug in the natural numbers, 1, 2, 3, 4, so on. We're not allowed to plug in fractions or decimals or negative numbers or even 0. And since the numbers we can plug in are 1 through infinity in natural numbers, we say that sequences have a natural order. And we learned some of our notation. For example, our first term was always A1, our second term was A2, our third term was A3, and so on. And our general term would be A sub n. Okay? Now, what we were talking about, we just had a very general sequence last time. We had all kinds of different relationships between the numbers. In 8.2, we're going to be talking about a very specific kind. We are talking about the kind in which each term after the first differs from the preceding term by a constant amount. Okay? And the difference between consecutive terms is called the common difference of the sequence. Basically, what this is saying is that to get the next number, whatever it is, we're either going to add or subtract the same value. Okay, so in this version, A1 is always the first term. And then the difference between consecutive terms is called the common difference of the sequence. We use the letter D to stand for the common difference. Now, technically, we're adding the same value each time. It's adding if our common difference is a positive number. It's essentially, we're adding negative numbers every time if D is negative, which is subtraction. Okay, so let's try writing the first 6 terms of an arithmetic sequence. And we're told that our A1 is -7 and our D is 4. Now, I'm going to write this out in a way that's going to help us see where this next formula comes from. I'm going to be writing down more on this problem than what you would normally do, okay? So our A1 is -7. That's like a freebie, it's given to us. To find A2, we would take -7, and we're going to add our difference, which is 4, and we get -3. Okay, now our A3, again, I'm going to be, normally on this problem, you would just go ahead and do this arithmetic. You're adding 4 every time, you're going to get there. Again, I'm doing something special here so that this makes sense. A3 would be take the one before it, and yes, I'm writing out this part, which makes it seem weird. Add 4 again. Well, this would be the same thing as -7 plus, since we're adding the same value here, this is the same as 2 times 4. Okay, -7 plus 8 would be +1, which is the same thing as taking -3 and adding 4 to it to get a 1. Okay, leaving myself some space here for reasons that will be clear later. A4 is the same thing as -7 plus 4 plus 4, and then add another 4. And this is the same thing as -7 plus 3 times 4, which would be 5. Okay. A5 is the same as -7 plus all of this, 4 plus 4 plus 4, and then add another 4. So this is -7 plus 4 times 4, which would be 9. Okay, and then one more, A6, underline right there. This is -7 plus 4 plus 4 plus 4 plus 4, and then add another 4. So this is negative 7 plus 5 times 4, which would be 13. Okay, now why did I do this? It's so that you can see the relationship as shorthand. If we're actually write it out, everything we're doing, we're adding 4 every time, and this gets awfully ugly. But compare this to what we have right here, okay? First of all, this first number is always negative 7, right? That's always there. If you compare this to right here, this is how we write the nth term, or a general term, of any arithmetic sequence, with the first term is A1, and the common difference is D, okay? We'll compare what we have right here. This first value is always our A1, which is true here, okay? Our D, our common difference, is the number we are always multiplying by right here. Now look right here. I could write this one as plus, I'm not adding any 4s, so 0 times 4. And I could write this one as plus 1 times 4. Same value, right? Well, look what happens right here. This is 4 all the way down. So 4 here, 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 and here. That's our D right here. Now look at this value. For our first one, it's times 0. For our second one, it's times 1. For our third one, it's times 2. 4 times 3. It's always 1 less, isn't it? So if I'm looking for a 20, this would be negative 7 because it's always negative 7, plus it's going to be 1 less than this if we look at the pattern, times 4. Okay, so this would be negative 7 plus 19 times 4, which I do not have memorized. So this would be negative 7 plus 76. So this answer would be 69. Okay? The general formula comes from this. This type of thing happens every time because we're either adding or subtracting the same number every time. That ends up being a repeated addition. And anytime we have a repeated addition, we can change it into a multiplication as shorthand. That's where this formula comes from. This is something you will need to know because you're going to be asked to use it a whole lot. Okay? So for an example, find A sub 60 when our first term is 8 and our common difference is 6. You can, in a pinch, start adding 6 every time and then keep track of your 60th term. You're likely to mess it up because you're going to end up counting wrong, but it will work. But you really don't want to do that if you don't have to. We're going to use this formula. I want to find A sub 60. So our N is 60. Our A1 is 8. Our D is 6. A sub N, that's how I found out my N was 60. Okay? Now let's just plug this in. Our A1 is 8 plus N minus 1, 60 minus 1, times our common difference, which is 6. So this is 8 plus 59 times 6. 59 times 6 is 354. So our 60th term would be 362, which is a lot easier than writing out 60 terms and figuring out where that is. Okay? All right. Let's do one more. We want to write the general term for this sequence: 6, 1, negative 4, negative 9, and so on. And then we want to use that to find A sub 20. So we have two parts here. We're going to use this information to find A sub n, and then we're going to use our formula for A sub n to find A sub 20. Now to find these, we need to know A1, our n, we can leave as n at first, and we need to know our d. Okay, Well, what is our A1? It's always our first term, so A1 is 6. Now, we're not told what D is, okay? So we have to figure out what we're adding or subtracting every time. What is our D? Well, to go from 6 to 1, I subtract 5. Let's just use our calculators to make sure that this is working, okay? To get from here to here, I subtract 5. Let's see if that continues. I have 1. Subtract 5 again, it gives me -4. Subtract 5 again, you get -9. So that's what's going on every time, right? So what we're doing is we're subtracting 5 every time, so we say that our D is -5. Technically, we're adding -5 every time. You know that there's a relationship between negatives and subtractions. Okay, so let's use our formula to find A sub n. Our general formula is A sub n is equal to A1, which is 6, plus n minus 1. Our n, we're just going to leave as n, because we're finding our general term, so we don't know what n is, times d, so times -5. Now what I'm going to do is I'm going to make this look nicer. Normally when we have a number in front, we put it right here. So this is really what this is 6 minus 5 times n minus 1. That's how we would normally write this before we distribute. Now I'm going to distribute the -5. To simplify this, I get 6 minus 5n plus 5. So this is simplified 11 minus 5n. Okay, so this is our general term. This is what we would be looking for. Now they want us to use this to find A20. A sub 20, this is general, so I can go ahead and plug this in right here. What we've done here is we've basically done the algebra and the simplification for every single n value we could possibly plug in. A sub 20, this is the same thing as 11 minus 5 times 20. So this is 11 minus 100, which is -89. And just to make a point, I could have used this again right here. If we had done it that way, if we'd gone back to the formula before we simplified it, I would have A sub 20 is equal to, I can barely get them on the same screen, okay. It would be 6 plus 20 minus 1 times -5, which would be 6 plus 19 times -5, which would be 6 minus 95, which is -89. It's just this one did more of the work for you, so that plugging in a new number was a little bit faster.